are you guys doing? Good. You enjoying day number 2? Good. I'm enjoying it because this is my last session, and then I get to hang out like the rest of you. All right, so let's go ahead and get started. This session is called Effective TypeScript. And before I begin, just a few words about myself. My name is Kito. You can find me on Twitter there at Kito99. I'm the principal consultant at Virtua, which is a little consulting firm that does training, architecture, mentoring, and development for front-end technologies and back-end technologies. We're also an official partner for Prime Faces, Prime NG, Prime Vue, Prime React as well. I wrote a book a long time ago. Yeah, that's kind of old. All right, so I also I'm a co-host of a podcast called Enterprise Java Newscast. We are changing the name to Stacked because we're focusing both on front-end and back-end and different technologies. But if you like podcasts, you should check that out. We're now part of the Pubhouse network, so there's a couple other Java podcasts that are part of our network as well. I'm a Java champion and a Google developer expert in web technologies, and I speak at lots of conferences. So that's my story. And I wanted to hear a little bit about you guys. So how many of you consider yourselves first and foremost a Java developer? Okay. How many of yourselves consider yourselves first and foremost a JavaScript developer? Okay. How many of you consider yourselves a TypeScript developer? Okay. How many of you feel like you're like a TypeScript expert? All right, this may be boring for you. I have to warn you. So our target audience are people that have worked on maybe a couple of TypeScript projects, but you probably feel like you might be able to learn a little bit more about it. Okay. If you're new to TypeScript, this will be handy for you as well. Also, if you're leading a team of people working on TypeScript with varying levels of skills, this might be helpful to you as well because that's often my perspective. Okay. All right. So, first of all, why TypeScript? How many of you have a project that's JavaScript and you're not using TypeScript, but you're wondering about using it? Anybody? Okay, so a few of you. Well, basically, this is sort of my perspective, and I've worked with Java and JavaScript a lot over the years, right? JavaScript is pretty cool in some ways, especially now. Lately, it's gotten very cool, right? But it's somewhat flawed, okay? And a lot of this, I think, has to do with sort of old cruft, right? It was written very quickly initially, kind of thrown out there, but it's backwards compatible. Right, so backwards compatibility is sort of like the Achilles heel of Java and JavaScript in some ways, right? The language needs to evolve, but you want to make sure you can still run all the old stuff, so you can't just, change it completely. And a lot of JavaScript's nuances are kind of based on the initial design that hasn't really been changed. But we've gotten a whole lot of great features on top of that design. So it's become a really powerful language. It just, has some issues. So TypeScript is basically JavaScript that scales. It's open source. It's started and maintained by Microsoft. And one of the things that drew me to it, I kind of got into it because I was like, oh, this sounds great. As a Java developer, this will make my life easier. And then I found out the lead architect is Anders Hallberg, who is the guy that invented or came up or led the teams for C#, Delphi, and Turbo Pascal. Now, what's funny about this is that my first programming language was Turbo Pascal, and then my first paid work was Delphi. I skipped C#. I played with it a little bit, but didn't really get paid a lot for C#. But basically, it's got a really good pedigree. It's got some really, really well-designed features. So it is basically a transpiler. Right? A transpiler is basically something that takes code and turns it into other code, right? You can think of it like Babel, Tracer, or Clojure, right? But basically what it'll do is it'll give you access to all of the new features in TypeScript, in JavaScript, okay? And then it will transpile that to an older version of JavaScript that can run in the browser, because most of the features in JavaScript can be implemented using older JavaScript features, okay? It just looks very ugly when you do it, but it can be done. But the key benefit over and above like Babel is that it has an extensive type system that's built to work in the world of JavaScript, right? So the type system is not really, it's not the same as, you were sitting down to design a language and you came up with an awesome type system, It's not like that. It's more like they took a look at what people were doing in JavaScript and then came up with a type system to work with that, okay? So what's nice is that having that type system, probably one of the most noticeable features is you actually get useful code completion. Has anyone ever tried code completion or IntelliSense with pure JavaScript? And what do you get? I don't know what it is. It's usually, okay, it'll give you like, some methods that are on an object, right? But other than that, it's a whole bunch of stuff. It tries to guess what you might want to do, and usually it's wrong, right? With types, it knows what the type is, so it just gives you the properties and methods or whatever of that type. So it makes the development experience much nicer. And because of this, because it has types, it reduces errors. So the idea is that in larger applications, large-scale applications, having that type safety, in addition to the cool new features, makes your application more maintainable. Okay? But one of the things I've decided is that effective use of TypeScript requires that you actually understand the new JavaScript features and also the type system. Because I've worked with a lot of developers that use TypeScript but don't actually use the types that much. So you're not really getting the real benefit, okay? So I'm just going to review a few basic ES features. I'm not going to go over everything, but just reminders if you haven't worked with some of these features of what just some of the newer JavaScript features are, okay? So the first one, obviously, is the class syntax. Who here has used the class syntax before? That's most of you. Good. All right. So basically, and I'd say maybe 90% of these features are syntactic sugar on top of normal, older JavaScript, right? So JavaScript did not change the way it builds objects. It just gave you syntactic sugar to make it look like Java or C#, right? So basically, you can create a class. You can have a constructor. You can also extend objects as well, okay? So, and this helps developers like me that are more from like a Java background work with it, as opposed to I don't have to think as much about the way that prototypical inheritance works in JavaScript. Okay. Then of course there's let and const. Is anyone using var for JavaScript code? Oh no. Okay. All right. So let and const are really what you should use. You should pretty much never use var anymore. And basically they just mean that the variable is scoped to where you. Well, let means the variable is scoped to where you actually define it. So with var, let's say you declare a variable inside of a block, like a loop or something. JavaScript will hoist it to the top of that entire function, which is really confusing, okay? So let actually defines the variable to be in the scope that it's in, like if it's in a loop or another block somewhere, which makes sense. So let pretty much works the way we expect a variable to work, okay? Const just basically allows you to define a variable that you can't change, okay? And I really love const. I use it all the time. And actually, I find when I'm writing Java code, I use final var all the time, which is pretty much the same thing. So if you ever use var, final var in Java, const is pretty much the same thing, okay? Then, of course, there's arrow functions. And arrow functions fix another issue with JavaScript where it will give you where it's confusing about what this is, okay? So if you use an arrow function, and that's pretty much what happens if you use like a method in a class, okay? You basically end up with a function where this actually refers to the object that the loop is in as opposed to the object that's calling it, okay? So pretty much In most cases, if you're going to create a function, you should use an arrow function because it's just going to work a lot more logical in terms of what this actually means. Okay. So promises are pretty popular these days. Basically, a promise is just the idea that you can defer action of something and or have something do some work and then get notified when it's done. Okay. So here we've got a message after timeout. You send the message to what timeout. Return a new promise, and after it's done, it calls this resolve. And so basically here what's happening is you calling the method then is a method on a promise, and you're saying when you're done, return this, or call this code, excuse me. Another similar feature is async and await, which basically give you, I don't have a slide for it, but basically it gives you even better syntactic sugar for working with promises. So actually it looks like you basically write your code like it's iterative, but it's not. So when you say await, it actually will wait on a promise. So you don't have to do then and send in functions. It sort of just looks like you're pausing. So async and await are very handy for asynchronous stuff in conjunction with promises. Symbols are something people don't talk about too much, and they're really fascinating. So basically, they give you sort of a mutable object that refers to something, okay? But no two symbols are the same, okay? So here I've got two symbols with the name foo, right? But they're not equal to each other, okay? But I can reassign it, like I can assign another variable to this symbol, okay? And these are interesting. They're used internally in classes for the names of properties, which is handy. But also you can think of them as kind of a very clever way to handle constants, if you want. I don't see this used very much in application code, but it's something to keep in mind if you're trying to handle a more complicated use case, okay? But think of it just as something like each symbol has a unique identity, right? So template literals are another one. How many people have used template literals before? Okay, so a few of you. So template literals are similar, actually. There's actually a new feature in Java which is similar but not as good as this. But basically, you can have a multi-line string, right? But also, you can embed variables in it. So this refers to something in the context of this current block of code, right? So this is customer.name and card.amount, whatever. And they can be multiple lines, etc. So it's pretty handy when you have a longer string, and it's a lot easier to read and easier to type than a string concatenation. Okay. Destructuring is another one. This is where you basically can, from an object, pull out properties. So you don't have to essentially so you don't have to say, let's say, like in this example, AST node has these properties, op, LHS, and RHS. So you don't have to make multiple let statements to pull out those properties. You basically are saying, let me create these properties or these variables and set them to properties of this object. So this line right here is exactly the same as this, okay, without the temp, obviously, okay. So it looks a little weird, but it's actually handy for just making things a little bit less verbose, okay? Spread operator is another one. This basically has a couple uses. In this case, what's happening is we have a function, right? We're passing in 3 variables, and it returns a value, right? And we have an array. So spread will basically send in a variable or an argument, excuse me, in this function for each item in this array, okay? Now, of course, if there were 12 items, it would send in 12, but the function would only look at the first 3, okay? So spread, you can think of it as just actually spreading out the contents of something, okay? Another use case of spread is like this. So here we have 2 numbers, right? 2 arrays, the first one, the second one, right? And then we have creating a new one, and we're passing or adding to this array this is spread here. So this is, again, going to spread out the values of that array. Okay, And you see it's ABC 1, 2, 3, right? Because numbers clone is all of the elements that are in here, right? And so what you can see is that spread is actually a handy way to make a copy of something too, right? So in this example, we're making a copy of an array, right? But you can also use it to copy an object, okay? So this is essentially a shallow copy, and it's like object.assign, similar to it, okay? And you see window widget is not equal to clone because clone is essentially a copy of widget, okay? So this is very handy in cases where you need to make a clone, and this also is useful, especially when you're working with front-end frameworks that actually do things like change detection, like Angular, where unless you change the reference, it won't actually update the view accordingly. So you can use a spread operator to make a copy of your existing object, and then you'll force it to update the view. So pretty handy. REST parameters are handy too. And these are something that we have in Java, though they're a little bit different. But basically, you can just take as many parameters as you want here, okay? So my func whatever, and you can see over here, additional info is going to be an array of values, okay? So it's handy when you're writing a method to be able to take as many parameters as you want. So decorators, how many people have used decorators before? Awesome, okay. So decorators make me happy because they remind me of Java and C#. So decorators allow you to add a declarative, you basically add some declarative behavior to parts of a particular piece of code, okay? And these are supported by, I don't think all the browsers support them, but definitely Babel does and TypeScript do, okay? So this is an example. This is actually a Polymer component, I think. But essentially, we've got a class, right? And we're using this component decorator. So this says that this is a component. And this particular component decorator makes it a Polymer 2 or a Polymer 3 web component. I can't remember what this was. But, and there's other ones too. So property makes it a Polymer property. And this actually does some very specific things. I think I have an example for a couple of these. But a property in Polymer has certain behaviors, right? Same thing with the component decorator makes it an actual web component, an actual custom element, okay? Okay, and then here is an observer, which again is a method that gets called. So this is basically saying whenever this property of this component called recnum changes, call this method, okay? And this is an event listener down here. Let's listen, okay? This is actually, I think this is actually code from a project. So if we look at that component decorator, this is what it looks like. So a decorator is really just a function. And basically, it gets sent to it a tag name. In this example, this is a class decorator, right? So it gets the tag name and extends tag. And then basically, you can have it, there's a couple different ways to do it, but you can return a function, right? And the function takes as a parameter the target, okay? So basically what's happening when you call that component decorator, at runtime what's happening is it's going to go in, it's going to change is to equal tag name, okay? And tag name is this right here, okay? So it's the parameters that are sent into the decorator, okay? And then there is an extends tag that you can add as well. If it's not undefined, it adds that to the prototype of the component, of the class, okay? So basically at runtime, it can do some runtime manipulation on the object based on what you set on the decorator, okay? Which is really quite powerful, okay? And a lot of what decorators do is they take away a lot of the boilerplate, just like they do in Java. They're not decorators in Java, but the same idea, right? In this example, this is that listen decorator, okay? It takes as a parameter a string, which is an event name, okay? And it returns a target, a property key, and a descriptor. So this is a property descriptor. So it can actually change the properties of the object here, okay? And also what it's doing here is it's on the target object, it's making sure there's an object called listeners, or an array called listeners. Okay, so it's actually adding stuff to the object at runtime. Okay? So a big fan of decorators. Other features are modules. How many people have used ES6 modules or ES 2015 modules? Okay, so a few of you. How many people have used other module systems before? Like one of the many other ones? All right. So later versions of JavaScript have native modules. There have been other systems in the past that are basically proprietary modules, like AMD and, well, not totally proprietary, but System.js does some stuff like that. But there's actually native modules in JavaScript now, which are pretty cool. And they actually can run in the browser, so you can actually load modules directly into the browser without having to have a build step first. Async await, which I mentioned earlier. Generators and iterators. An iterator is pretty similar to an iterator in Java. You could just basically loop through items, or it's an interface to go through different items. A generator is a special function which allows you to create an iterator. But those are pretty cool. I suggest you take a look at them. One of the things I like are maps and sets. I mean, actual normal data structures, right? So as opposed to having to get a third-party library just to have a map, that's actually now part of the core language, which is kind of cool. There's also proxying and reflection now as well. Okay. Sometimes in the browser you need polyfills for these, but these are features that you can use. There's also internationalization and localization features as well. All right, and don't forget just getters and setters, because those are pretty handy things, and those are actually built into the language, unlike Java, which still doesn't have getters and setters like this. So those are always handy. So this is basically defining a property called name. So this is one that can be mutated. This one's a read-only property. And then, of course, there's that weird truthy-falsie thing in JavaScript. Anyone run into this? Truthy-falsie? Yay. All right. So, and I was looking at this. I was like, OK, what's the easiest way to categorize this? And it really is just to say, these are all falsie, and everything else is true, right? So obviously, if false, if null, it goes to false. If defined, 0, nan, which is not a number, or an empty string, those are all considered false. Okay. So just remember that when you're doing if expressions, etc., that JavaScript is a little weird that way. All right, so that's my quick tour of all of the ES features. Let's talk a little bit more about actual TypeScript. So TypeScript is a transpiler. It outputs JavaScript. It can target ES3 to ES-next. And there are some limitations. The further back you go, like ES3, you can't support as much stuff as you can with like ES5. Pretty much any browser, including IE11, is going to be ES5 or later. And how many people still use IE11 at their job? Damn. All right. Still too many. But I feel like in the next couple of years it'll finally be gone. I'm beginning to be hopeful. So, but one of the key things to remember about TypeScript is since it's a transpiler, everything that runs is still just JavaScript, right? So all the cool stuff TypeScript does is all compile time. Okay. All right. So I'm going to do one quick thing here. Okay, and I'm going to pick some random example. All right, that's not a good one. Here we go. Okay. Hello. Clearly, this menu does not work when you do it this way. Okay. Well, I'm not going to be able to show what I wanted to. Anyways, all I wanted to show was, it's not a good example. Okay. Well, anyways, if you want to play with TypeScript, check out the TypeScript Playground. And what it'll do basically is on the left-hand side, you can type TypeScript, you can look at these different examples, and on the right-hand side, it'll actually show you what the corresponding JavaScript is. I don't have time to do a lot on here, but if you want to get a handle on actually what's happening, what the transpiling process looks like, you can go to the TypeScript Playground. Just go to typescriptlang.org. You can get to it from there. Okay. All right, so a little bit on types. JavaScript has a few types, right? Not a whole lot. It has null, undefined, number, string, boolean, symbol, and big int, which is an ESNext feature. Okay, and those are the primitives, right? And then it has objects, and this includes function and array. They're both objects. And that's pretty much it. Okay. It also has symbols, which I mentioned before. Okay. And what's nice about a dynamic language like JavaScript is that you can reassign things to whatever you want, right? So you can assign this to this is a primitive, this is a string, and then you can reassign it again to something else, right? And everything just works fine, assuming that's what you're expecting to happen. But TypeScript is much more strict. Every variable has a type, which may be inferred. Okay, there's a lot of type inference going on. And rules govern which types you can assign to each other. Okay, so you can't just, if you say something is a foo, you can't assign it to a bar, basically. Okay. It also fully supports generics, which look familiar to you if you're used to Java or C#. So there's null and undefined, okay, which are actually types in TypeScript. Okay. So here we have a string. Default value is undefined, just like JavaScript, right? I can assign it to something, and I can assign it to null, and I can assign it to undefined. Everything works fine, okay? But there's several compiler options, and one of them, which is handy in terms of reducing errors, is strict null checks. Strict null check says, hey, you can't do that. You have to initialize it up front, okay? And unless you tell the compiler that this is allowed to be null or undefined, you can't do it, okay? So you can actually tell the compiler, we'll see that a little bit later, this keto can be a string or it can be null or undefined, okay? But with strict null checks, you kind of have to do that if you want to allow the value to be set to that, okay? And what that does is it allows you to cut down on errors where something is null and you're not expecting it to be, okay? There's also any, okay? And any in TypeScript is sort of like object in Java, because in Java, pretty much everything extends from object, right? But that's not true in JavaScript. So there really was no way to define something that could be assigned to pretty much anything. So that's what any is for, okay? So any is essentially the default type in JavaScript, right? So if you say something is any in TypeScript, you can assign it to anything you want, just like you can in JavaScript, okay? So, so these work because this value might exist, because the compiler doesn't know. It's like, well, you said it's any, so I give up trying to guess what it means, right? In this example, it's an object, though, okay? So it's going to throw an error if you do anything, set anything on this which is not on an object, okay? All right, and then here, we're saying this is an array of any, okay? Which means we can put anything we want in the array, okay? But if we said it was an array of int, or not int, of number, excuse me, then you would only be able to put numbers in there, okay? All right, so then there's also void. And void basically is, as you would expect, it's just no return type, okay? So if you have a function, you can say it returns void. And in TypeScript, it's optional. You can either specify the return type or not. If you don't specify it, TypeScript will infer what the return type is. So
it's 12 o'clock.
In case you were wondering. So if you didn't put this, it would just infer that it's void because there's no return statement, okay? Another interesting type, which I came across this, the more I looked at framework code, like Angular code, I saw never. I'm like, what the hell is never? What does that mean? Okay, so never is a weird type, and really all it means is that you're telling the compiler that this function is never going to return. Okay, so here, if you know the outcome is only to throw an error, you can say it returns never. The inferred type is never here because it's always returning an error, right? And here, this never actually returns, so it's never as well. So never is a unique type. Unknown is another one. And unknown is essentially a type-safe version of any, okay? So basically, this is basically you saying, all right, well, I don't really know what it's going to be, but if I ever tell the compiler that it might be something else, then let the compiler enforce that, okay? So here, we're setting it to 5, okay? But we set it to unknown. So it is 5, right? It's not equal to 10, but you can't call random methods on it, and you can't increment it or anything, because it's 5 right now, but the compiler doesn't really know what it is, okay? But you can always cast. This is essentially a cast in TypeScript. So this is saying, okay, I'm treating it as a number, and then that'll work fine. Okay. You can also do a cast in a more traditional Java-style syntax where you put the type in parentheses. You can do that as well. Okay. But here, this is really the more logical use case for unknown, right? So you can actually narrow the type here. So basically, if we're setting an unknown, but we're saying if the type of the object is string or it's number, then do something. And at this point, the compiler says, hey, I know what it is. I know it's going to be either a string or a number. So it'll treat it like one of those two things, and you can't do anything with it that's not allowed in a string or number. Okay? And the same thing goes here. If it's an instance of error, we know it's an error object, so it treats it like an error object. This is function method up here allows you to treat it like a function. Okay, so declaring something as unknown allows you to narrow the type based on some condition. Okay. Okay, so some more traditional types are an enum. Okay, this is similar to an enum in pretty much any language. Enums they have a name, they can have values. Okay, and you can use them in switch statements. Okay, and I use enums a lot. And what I find in a lot of JavaScript is developers will just use a lot of strings. But strings are just prone to error because you can have typos and things like that. So just throwing it all in enum makes your life a lot easier. Okay, so I tend to try and push people to use enums as much as possible, as opposed to just what I call magic strings. Okay. So enums can have values like numbers, but they can also have strings for values as well. So I've actually used this pattern in applications before where we have a whole bunch of messages. We know we're not supporting different languages. We're not loading the messages from a server, but we want to put them in a central location. So you put them in a particular, like a constants file or something, and we put enums in there, and that's where all our messages go. And everybody knows that that's where the messages are stored, so they have a consistent message. Okay. So another type is a tuple, and a tuple is a weird thing. So basically, the idea with a tuple is that you tell TypeScript some types that are in an array, and it basically will sort of require those types for the elements that you specify, but then make guesses about what else might be in there. Okay. So here we say string number, right? So it is going to assume it's basically assuming the first two elements are string and number, right? But and if you access this stuff, it will work, assuming you're doing something of the right type, right? So subster is not on a number, so this doesn't work, right? But when you access something outside of the known index, it's like, well, I don't really know which one it is, but it must be a string or a number. So in this scenario, like when we access the third element, if there was another element in this array, it's okay with it being a string or number, but not anything else. Okay. So it's kind of an interesting type. So you can also have intersection types. Okay. So this is basically, there's an extend method here, which is basically just copying all the properties from two different types into a new object. Okay. So we have two different types down here. We have a person. Person implements, actually we have a person and we have an interface loggable. The console logger implements loggable. Okay. And then we call extend. And extend gets a person and a console logger. And essentially, it can also call log, okay? Because we basically just copied, basically we mixed in two objects together, right? But the type of this is this. It's, in this case, it's person and console logger, okay? So you can actually define something to be an intersection of two different types, okay? Which is the and syntax. Union is another one, which I use a lot. This one's handy. So basically, in this scenario, you're saying that something can be, string or number, right? So this pad left is going to act differently if something is a string or a number, okay? And this is also useful if you're, if you're defining a method signature and you know that you can use a couple different types, or if you're trying to find a way to express a particular type and you can't quite figure out how to do it, you can do it with union types and just make 2 or 3 and then make the type that you are using be all 3 of them, okay? Or one of them, excuse me. So that can be pretty handy. So here's another example of a union type. And this is also very handy if you've got like a string property, okay? So if you have a string property, but you don't want people to mistype it, and you're not making it an enum, another way to enforce the actual values is to just use a union type. So here we're saying the style cannot be anything other than one of these 3, okay? And that's very, very handy when you have a string value that you want to control the typing of. So now if someone tries to set the style and they mistype accordion, it actually will not compile, okay? There's also index properties, okay? So we've got a couple objects here, person. This is the interface, and then we're creating an actual new person, okay? And you can actually do this. Let person keys equal key of person, okay? So this is going to be one of these particular values, one of the keys in this object, okay? And then this pluck will basically go through the names and create an array, okay? So this is going to basically pluck this name out of the person, okay? So those are pretty handy too, especially if you want to know all the keys that are in an object. So TypeScript's type system is what we call a structural type system, okay? And basically that means that it's based on, the structure of the data, the shape of the data, okay? We talked about that. And it's what and because it compiles to TypeScript or transposes to JavaScript, excuse me, it's considered an unsound type system, okay? And that just means, there's probably some math that doesn't work. I don't know enough about type systems to know exactly what that means. But there's essentially edge cases that the type system doesn't cover because of the way it was designed, which is to work with existing JavaScript. But the basic rule is that if X is compatible with Y, it has at least the same members as, if X is compatible with Y, and X has at least the same members as X, then they're the same. There's a missing little text there. So basically, if you see this interface widget, or interface weight, right, it has a weight, which is a number, okay? And here, we have sort of an inferred type, okay? So basically, TypeScript is saying, okay, well, this is an unnamed type that has these values, right? Okay. So you can actually assign y to x because this has at least that property, right? But you can't do it the other way around because this has more properties than that, okay? So a lot of what you'll see when TypeScript is you'll define interfaces to basically give you a type-safe way to access JSON objects, other data, right? But you can also use it to basically define any particular shape that you're working with. And even if the object type is different, as long as it has the same properties, it all still works, okay? So in this example, we have a widget, right? And this widget packager takes a widget object, right? So first, there is this actual widget, which is this W up here, right? Which has name, weight, and color. And then we also pass in an object literal, right? This object literal has exactly the same properties. But because it has exactly the same properties, it has exactly the same shape as a widget, it actually can be passed into the widget packager just fine, okay? Whereas this one, this x down here cannot be, because x is not equal to the same thing. So, all right, so another thing to remember is that it's useful to have types for external libraries. So often you'll have developers, they'll be working on the team, they'll be cranking out some great TypeScript, and they'll pull in library X, and they won't use any types in it. And it's like, okay, so great. We've got all this great type-safe code, and you're using this whole library and not using any typing on it. So the most important thing to do is make sure that if you are using a third-party library, try and get the types for it. And maybe like 80% of the cases you can get types. You basically can do npm install and types in the name of the library, okay? Some libraries will include the types in the actual repo itself. So if you declare a dependency, you get the types for free, okay? And that's usually the best you can do. If you're really, really into it, you can write your own type definitions yourself if they don't exist. But I encourage you, if you use any third-party libraries or your developers on your team do, to try and make sure they actually use the type definitions for any libraries that they use. There's also this file search here, which is handy if you want to see if they have it. All right, and what you can do if you can't find the types, you can just basically declare any, which is ugly, but you can do it. You can declare that library, and then if you want, you can add some types to it if you want to give it some shapes. So, all right. So just a reminder, there are a whole bunch of cool compiler options. Just look at the docs. Experimental decorators you got to turn on because that's what you need for decorator support. Obviously, you can specify the target. You can do no emit on error, which is good because if there's an error, then you won't generate JavaScript. Sometimes you'll have a situation where things are working. You're like, why is it working? I thought the compilation failed. And it's because it generated JavaScript files that you're working with. So it's good to turn that on. Also, strict is a good thing. If you have a new project, turn on strict. It basically turns on all these things. It's very hard to do on an existing project, but a new project, you can be very strict about nulls and all that kind of stuff. So highly recommended. All right, so bottom line, effective TypeScript requires understanding new JavaScript features, using the TypeScript type system, the other features, other language features, and setting up your project to be as strict as possible. And also, even if you can't set it up that way, just try and remind people and remember to use the types and understand the type system and make the most out of it. Okay. All right, looks like I don't have time for questions, but you can come up after if you like. Here are some links for you. Thanks for coming.